Hello, puzzlers! I thought today we could start with a quick puzzle. And it is this. What do the following three words have in common? The word for in English, the word cinco in Spanish, and the word tre in Italian. What do those three words have in common? The word for in English, spelled F-O-U-R, the word cinco in Spanish, C-I-N-C-O, which means 5, and the word tre in Italian, T-R-E, which means 3. The answer, and more puzzling goodness after the break. Hey folks, welcome to the Hello Puzzlers podcast, the flow velocity in your puzzle Navier-Stokes equations. I have no idea what those words mean, but I Googled best equations ever, and it was in the top 10, so thank you, Navier-Stokes. I'm your host, AJ Jacobs. I'm here with senior puzzler Andrea Schoenberg. Andrea, before the break, we asked the riddle, what do the following three words have in common? The word for in English, cinco in Spanish, meaning 5, C-I-N-C-O, and tre in Italian, T-R-E, meaning 3.
Well, it helped that you spelled them out immediately after you said them. I think that was a good, fat, juicy hint. So thank you.
You are welcome.
They have the same number of letters, or they have the number of letters that are the
yes,
numbers that they are. That's hard to describe.
It is hard. Yeah, they are all number words that contain the same number of letters as the number itself.
Exactly.
That's how I did it, but I had a little more time.
No, that was well put. That was much better put than I.
It's fine.
It was
hard though. Yes, F-O-U-R has 4 letters. Tre in Italian is 3. T-R-E and cinco is 5, and it's actually an unusual property. I searched a lot of languages, but I did not find many words with this characteristic. 1 in English has 3 letters, 2 has 3, 3 has 5, 5 has 4. Don't get me started on like 20 or a million or a billion like that. They just fail massively. I bring all this up because today we have with us math royalty. We have the great Grant Sanderson, the man behind the massively popular YouTube channel 3Blue1Brown. If you don't know him, Grant creates these very cool visualizations about all things mathematical, how Bitcoin works, what the heck quantum computing is. And my son Jasper says that Grant is the best celebrity get that we have ever gotten on the show today.
Aww.
Very excited. Welcome, Grant.
Oh, thanks for having me, AJ. This should be fun.
Oh, we are excited. Your videos rack up millions of views, and 2 of the more popular ones are about the math behind Wordle. So as a puzzle podcast, we have to start there. Can you give us a quick summary of what you discovered with your Wordle math?
Yeah, sure. So, I mean, this was right when Wordle was really hitting the scene. If you were on any social media at that time and you saw those colored squares, this is popping up. And so I like word games too. I'm not just a math person, and so I enjoyed Wordle. And I think anybody who programs would see this and say, this is actually a pretty fun programming challenge. But what I wanted to use it for was a Trojan horse to teach people about something called information theory. It's not the only way to think about it, but broadly, there's this field that was founded by Claude Shannon and Bell Labs in the 1940s. He was the one to coin the word bit. So bit didn't exist as a word, and he invented it to try to describe this concept of like, how do you measure information? And the loose idea is if you have a broad set of possibilities, the fewer possibilities you have when you discover one of them, that only gives you so much information. But if there's a huge number of possibilities and you discover which one is, the reality, that gives you a lot of information. So in the game of Wordle, you can turn this into code where you might say, what opening guess gives you the most information? You can turn that into a piece of math. You can say, no, really, what is the number that tells you which specific opening guess gives you the most information? First, we have to define information. And so the video is kind of an excuse to give a lesson on that. But one of the motivating examples there, I had been having this chat with a friend who also enjoyed Wordle, and he mentioned always opening with the word weary. I'm like, weary? Interesting. He's like, I know. But that W, if it does hit, it just feels so good. I'm like, okay. And so I used that as an example. I'm like, I get it, But the rarity of hitting it also corresponds, you get more information when you hit it, but it's less likely that you hit it. So when you try to ask what's the expected amount of information, which has a fancy word, it's called entropy. And yes, it is connected to that other entropy that you might have heard of. Like it was just good fodder for discussion. And so I wrote this, I made the program and saw, okay, what's the best opening guess that gives you, it's not just a matter of information, it's also what gives you the best expected score. And I made this video, and then the opening guess based on the words that were used at that time. This was pre-New York Times acquisition. The opening guess that was best, according to me, at that time, was crane. I'm like, here, put it in the thumbnail and everything.
CRANE.
CRANE. Which is wrong. There was a bug in my code. Some things are so elegant that they're wrong, and this was one of those. And so then a little bit later, I put up a correction. It's like, wait, okay, it wasn't crane. I forget what it actually was. I think
I remember actually. Well, I just recently saw it. I believe it's Salet, SALET, a medieval helmet. Well, first of all, I love that you broke it down. Secondly, I love that you admitted that you had a bug, because that's such a good lesson for people that,
it's okay to be
wrong. If you make a
wrong.
mistake, that's fine. Just
we all make
correct
mistakes.
Salet was the one. But then you said, maybe as a human, it's maybe not necessarily the best.
Right, because the way we play is totally different, right? In this case, it's doing this ruthless process of like filtering down what the possible states are, doing this kind of expected number of guess calculation. And like the way that we think, it's so much more heuristic, where, we think in terms of vowels or there's certain common letter placements. Or there's also like the vibe, right? You're like, yesterday they did a really weird one that was, kayak was the answer. By the way, kayak, literally the worst opening guess, mathematically speaking, the worst opening guess.
Oh, and that's a good fact.
Yeah, and so you're like, maybe they're going to be cheeky to, right? There's all this sort of, the way you play any other puzzle game, where it's not just a matter of like
the human element.
Yeah, like just exploration of the infinitude of possibility.
So do you still play Wordle, or?
I got to be honest, it ruined it for me. Yeah, I could never play it after that, because I'm like, I don't know, the bot's I wrote the bot that's going to do better. Like I'm going to go do connections instead. It was lost.
Does the bot play every day? Maybe that would
Oh,
work.
no. I should have set it up. Yeah, I don't know why I didn't do that, just for the satisfaction.
Right.
No.
And when you did play, was Salet your opening guess, or no?
I stuck with crane. I just liked crane. It felt
that's
good.
a real word. That's a real word. We're going to talk more about puzzles and math, but first, since we are a puzzle podcast, I have a puzzle for you. And this puzzle is called, which really big number is bigger than the other really big number?
Okay.
Very catchy. So I'm going to give you two quantities, and you're going to estimate which is the higher of the two quantities. So, for instance, which is higher, the number of grains of sand on all the world's beaches, or the number of nanoseconds of content uploaded to YouTube every year? And we're talking estimates, of course, because it's hard to make exact counts. We did try to use the best sources like Scientific American, peer-reviewed papers, but they are estimates. So in that case, what do you want to guess?
Boy, so per year, I mean, that's going to get us, I don't know, I got to say it's more nanoseconds per year, because
look at that. He was not
16.
fooled. He was not fooled. Yes, according to our rough estimates, it's about 100 quintillion nanoseconds per year, because a nanosecond is a billionth of a second, I believe.
Mm-hmm.
So that's a lot of zeros. That's one with 20 zeros after it.
Okay.
And grains of sand, according to Scientific American, is 7 quintillion, 7 with 18 zeros. So 20 zeros beats 18 zeros, and there you have it. So YouTube pounds sand. Okay, so are you ready?
Let's do it. Okay, which big number?
Which is bigger, the total number of ants on Earth right now, or the total number of letters in Wikipedia? Total number of ants on planet Earth, or all of the letters, the characters, and all of the entries in Wikipedia worldwide. What do you think?
Interesting. So I am remembering some people had this, I don't know if they actually made it or if it was just a concept of printing out Wikipedia. What would that look like? And it was like thousands of volumes, right? And so I don't know how to use that as a start to say like how many letters there are. But let's say on a given book, I don't have a good sense of how many are in a given page.
Well, I can tell you the books I write are about 80,000 words. Does that help?
Well, tell me how many pages are in the books.
Oh, about
roughly?
200.
Okay, so you've got 80,000 over 200. So your 8 over 2 is 4. You're losing 2 of your zeros. So we're getting like a couple hundred, like 400 words per page. Maybe these volumes that they were printing, maybe they were being a denser. So let's say like 1,000 words per page. And I don't know if they're going to make them big, maybe 1,000 pages per each one. So that's like 1,000,000 letters in each one of them. And so if they have on the order of thousands, that feels small though, like billions of letters. Like I feel like it should be even more than billions of letters. So I'm going to have this fudge factor that throws me up a couple orders of magnitude where I just feel like it should like a billion bytes of information. Like I feel like there's more than a gigabyte that must have been uploaded to Wikipedia. So I could be way off, but I'm going to throw it into the hundreds of billions to trillions, something in that range for Wikipedia.
Pretty
Now,
good. I'll just
ants,
say.
there's so many ants. Like each colony is like the analog of an organization, of an organism, biologically speaking, right? That's sort of like a colony functions more like an organism elsewhere with its like single point of reproduction. So there's got to be way, way more than humans. So if we're talking 8 billion humans, again, I've got to throw it up by like 2 or 3 orders of magnitude for ants. And so I'm inclined to guess that we're on the order of 10 trillion ants, and there were in the something hovering around 1 trillion Wikipedia characters. And so I'm giving it to the ants on this one. But
You did it.
okay.
You did it. I loved watching you go through that. That was a lesson in itself. According to our best estimates, the letters in Wikipedia are about 225 billion letters.
Okay.
So you were right. Hundreds of billions, you said at one point. Quadrillion, 20 quadrillion ants. So
Okay,
that
so
is
I
two with
was 2 orders of
16.
magnitude off there.
Yeah. Listen,
Yeah.
plus or minus a couple orders of magnitude. It's not bad.
Maybe the other like intuition there. I went to see a solar eclipse in the northwestern tip of Australia a couple years ago, and getting to that part of the world is very remote. And this involved driving north from Perth. And as you're driving, there's nothing that you can see, nothing, but just this almost infinitude of a sea of termite hills.
Interesting.
Where as far as the eye can see, you just have like millions upon millions of these termite hills. And so I remember that being one visceral moment for like, there are a lot of insects. There's not just like many. There are an unfathomably huge number that are just lurking in all of these unpopulated parts of our planet.
But they are all beautiful individuals with their own soul and personality.
Yeah.
Maybe.
It's according to the movie Ants, which I'm inclined to.
Exactly. That was a good scientific movie. Yes, there are just a crazy, mind-boggling amount of ants. All right, I got another one for you.
All right, lay it on me.
Which is bigger? The number of ways a deck of 52 cards can be arranged, or the number of stars in the universe?
Okay, this one, I feel like I just know right away. Like I can talk through how I'm going to think about it.
I thought you might. But
there is no way that permutations of a deck of cards doesn't win out on this, and by a lot, I think, because I think when you do a lot of math or computer science, you get a sense of that. We have a word for it. We call it combinatorial explosion. Where combinatorics is the field of counting stuff, which at first sounds silly. You're like, it's the math of counting. And you're like, hang on a second. My 3-year-old learned that one. But you have these questions of just how many. So in this case, how many orderings of a deck of cards are there? Or how many 5-card hands could you draw? How do you answer questions like this? And very often, as you're answering these sorts of questions, you find yourself multiplying a lot of things together. So to order a deck of cards, you say, what could the top card be? Well, there's 52 choices. What could the card right below that be? Well, we've already used one of them, so there's only 51 choices. What about below that? Well, we've used 2, so there's only 50 choices. And these are all independent of each other, so you're going to have 52 times 51 times 50. And so you try to think, like, how big is that? 52 times 51 times 50 times 49 times 48. And if you just punch this into a calculator, the word explosion will feel apt, because quickly you'll be like, I see. These get very big very fast. And you can loosely estimate, like, if this is an extremely loose estimate, but each of these numbers that you're multiplying, they're 2 digits. A lot of them are, not all of them towards the end. But like if each one of them was the number 10, so if instead of thinking 52 times 51 and on down, you're just like 10 times 10 times 10 times 10, you're going to get a number with 50 zeros following it because it's 10 to the 50. So really you have something bigger than that because a lot of what you're multiplying was bigger than 10. But as a very, very rough floor, you're above 10 to the 50. Now, stars in the universe. So you're talking on the order of hundreds of billions in our galaxy. But our galaxy, and so hundreds of billions, that gets us, a billion is a 1 with 9 zeros followed by it. So 100 billion, that would be 11 zeros followed by it. Now there's a lot of galaxies. I don't even know. Do we even know how many? Like, I don't know how well defined this is, but there's a lot.
I mean, it depends. NASA has one number, Scientific American has another, but they're both big. They're both big.
But think, in order to go from where we are now, which, stars in our galaxy on the order of 10 to the 11, even to get to that super rough floor that we had for a deck of cards, which was 10 to the 50, you'd have to be getting 10 to the 40, which, I don't know, maybe something like that. The loose number I have in my mind for atoms in the universe is like 10 to the 80. I'm sure that's just like kind of made up because how on earth would we know? But so deck of cards, I don't know exactly. 10 to the 50 feels quite low. Maybe it's closer to 10 to the 80, but like definitely just going to be way, way more than stars in the.
You are so right. The cards kick the stars' ass. As you said, the 52 factorial, so 52 times 51, is about 8 times 10 to the 67. So 8 with 67 zeros. So 50 was a. And Andrea, I asked her, well, how do you say that? She says it's 80 ungvigintillion. 80 ungvigintillion. Rolls off the tongue. And the stars, it varies, but the biggest estimate is 1 with 24 zeros, so 1 septillion. So that's a big difference. That's a lot of zeros. But I loved seeing how you went through it, and you talk in your videos about making things simpler. So the idea of doing the 10, for the cards, that was great. All right, well, we'll do one more. Okay, this one I'm going to do because my father is obsessed with February 29th. He likes to tell people his birthday is February 29th, which is not true. Sorry, it's February 26th. But which is bigger? The number of molecules in a typical 8-ounce glass of water, or the chances that 4 random people were all born on February 29th. So the number of molecules in a glass of water, or the chances that you take 4 random people from planet Earth, what is the chances that they were born on February 29th? And by the way, I'm looking for the denominator, like, not 1 in a million. I'm looking for the million.
Yeah. The probability is smaller. Got it. All right, so you go to February 29th roughly once every 4 years. It's not quite every 4 years because you have other rules on leap years, but roughly that. And so if there's 365 days in a year, that times 4, I don't know if it was 350, you multiply that by 4, that's going to be 700 times 2, so like 1,400. I mean, a little bit more than that, like 1,450, something like that. So if you want 4 random people and, birthdays are uniform across all these days to be that, you're looking at
which they are not, because some months have more people getting born in them.
People are bored in winter and have not much else to do, so you're going to have a lot of fall babies. I think
although there's winter on the southern hemisphere is different than winter. So.
Good point. So assuming uniformity, because, we're doing estimates, so all cows are spherical, then
I like that phrase.
That 1,400, if you're going to raise that to the 4th power, so 1,000 to the 4th power is going to be, that's 10 cubed. So that would get you a 1 with 12 zeros behind it. We've got that like 1.4 in front of it. 1.4 squared is about 2. So that to the 4th power is about 4. And so we're going to have something like 4 times 10 to the 12th is your denominator there. So 4 trillion.
It is about 1 in 4.5 trillion.
Hey-o.
That was amazing. Look at that, people.
Great.
All right, now do the same thing with water. How are you going to do that?
We are nowhere close. Okay, because water shatters this. I thought it might be closer actually. So water shatters it because people might remember from high school chemistry Avogadro's number, which is oh God, I'm not remembering. I think it's supposed to get you something like how many protons in a gram, and so water, how many protons does it having, I don't know, you've got like
H2O.
18 from the O, protons or neutrons, and then two more from those. So it's like 20. But so if you were to have Avogadro's number of water molecules, and Avogadro's number is like 6.023 times 10 to the 23rd, that would get you, I guess, like 20 grams. So that's less than a glass of water. And that's already, you're into the 10 to the 23 realm. So you could have asked for 8 people to have
I thought of
leap day birthdays. Yeah.
Yeah.
And
We
that
have
would-
4 people in our family, so that's why I did it. But you're right. Yeah, water just trounces February 29th. Well, great job, Grant. That was like a 8 quadrillion out of 10. That's what I rate it. So we'll be back in a moment with more Grant Sanderson and Puzzles and Math. Hello, puzzlers. Welcome back to the podcast. We're here with Grant Sanderson, the man behind the awesome YouTube channel 3Blue1Brown, 8 million subscribers. Grant, I'm one of them. I have another puzzle for you in a bit, but first, we have a little segment called Puzzling Questions, where we get to know our guest a little better so they can be less of an enigma to our listeners. So I got a few for you. Let's start with a little bit about how can we overcome math phobia? Well, people complain, for instance, like, what does math have to do with my life? Why? And you have pointed out correctly, math is everywhere in the real world. Could you give us some examples of where we can see math when we just look around?
Sure. Well, let me start by saying it's not clear to me that that's the right way to address math phobia, to go to the applications. Like, I think it is true, right? And so you see math everywhere. This is more true now than ever. Like, machine learning is in the zeitgeist. Everyone's talking about AI. It is just a pile of math. More specifically, a lot of this field called linear algebra, where it's a way of organizing numbers. Well, there's 2 ways to frame it. The way that the mathematicians would not like me saying is it's a way of organizing numbers into like grids and using those for efficient computation, and then yielding insight from this like big pile of numbers that you have. It gives us this tool for that. It's that same field. So if you ask someone, what do you need to know to get into AI? They'd be like, oh, make sure you really know linear algebra well. That same field is also the answer you're going to get if you want to understand quantum mechanics or some of the fundamental laws of how the universe works. And that fact in and of itself is kind of interesting, that the laws with which the universe are written leans on this certain kind of math, linear algebra, and then what we do with computers. And it's for very different reasons, right? It doesn't look or feel like doing quantum mechanics. It's not like that's what's going on. It's just that same piece of math is quite general and useful elsewhere. But there's a lot of other stuff too. Like, I tutor my nieces just simply for fun because I want them to love math. And in my, like, how am I going to make them love math curriculum, it's much less centered on, hey, let me show you where we're going to apply it. Because honestly, it's going to be a little while before we're like really actually applying it in an engineering sense. But there's all sorts of delightful little puzzles that change the way that you think and kind of clarify how you can organize your thoughts that can be sharpened. Like that version of thinking can be sharpened in the context of these puzzles that have to do with counting. And once you organize your thoughts better in that setting, it just kind of makes you a clearer thinking person in other ones. And so I think 2 ways to view math and saying what can we do to make it such that fewer people hate it. Number one, I think they hate it just because they don't understand it. And because you've got this environment around, the only time you saw it was in a classroom setting where you're getting graded on it. And it just really doesn't feel good to like get stuff wrong and have this big red X around that. Whereas you can have the same thing happen in, I don't know, in like athletics or in like doing puzzles, where like people love puzzles even though they're regularly wrong and they regularly miss it. In fact, that kind of makes them more fun because you've never gotten someone saying, that crossword that you did on like Saturday, like going to give you an F for that. We're going to see if we can get you a tutor to work up your grade. It's like, I don't know. It was hard and you knew that you didn't get it and you kind of want to get better just because it's fun, but no one was ever telling you like, we need to, it has a certain emotional overtone once it's in the setting of a math class. But I think focusing on application risks missing the point of what makes math delightful in the first place.
That is great. Well, I mean, one of your answers to this is talking about how math can be a mystery story, like with a surprise ending. And I'm not going to ruin it because people should watch your videos about these blocks that bounce off each other and bounce off the wall. And it is such a crazy surprise ending. I laughed out loud because
That's great.
there's a number that is revealed that we will recognize, but it's like, what? Where did that come from? You mentioned math is good at teaching you how to think, but I thought we could go through a couple of simple classic math puzzles and what they reveal about the way we think. So I'm sure you've heard a bat and a ball cost $1.10 total. The bat is $1 more than the ball. How much do each of them cost? So walk us through the solving of that.
Sure. This is the classic example because something psychologically about language makes all of our brains want to say that the ball is 10 cents and the bat is a dollar more than that. And it's not like the math is hard, right? Because all you have to do is you check. You're like, okay, if that was the case, then together they cost $1.20. And so if you start thinking about it at all, this is not a math lesson. It's not like a lesson about, oh, here's some advanced algebra. It's just, have you thought about it at all? So there's something psychologically happening for why, bat costs $1 more, where it just feels very round, and like your brain doesn't want to go to the answer, which is that the ball is 5 cents and the bat is $1.05. But as far as how you can get there, I think, okay, so you can do it algebraically, sort of the right way. But like if you're teaching this to a 5-year-old, I think it's fine to have them just guess and check, and they'll build intuition pretty quickly. They guess 10 cents for the ball. They think it through. They're like, oh wait, that would combine to make $1.20. If it was 0 cents for the ball, that would be $1. So I don't know, halfway in between. I think the openness to saying, hey, just explore it, have a moment of being comfortable being wrong and then correcting yourself. Maybe that's the right way to engage with this one is, even a 5-year-old, they could just they could get to the right answer as long as they think about it.
Right. Trial and error and being okay with being wrong.
It's okay
I like
wrong.
that.
Yeah.
Here's another one that you talk about in one of your videos, and it's another classic. So Steve is a very shy and withdrawn guy. He loves structure and order, has a passion for detail. Is it more likely that Steve is a librarian or a farmer? A librarian or a farmer? So walk us through that.
So this one comes from these two psychologists, behavioral economists, Daniel Kahneman and Amos Tversky, who did a lot of foundational work in that field. People might be familiar with it through the book Thinking Fast and Slow. They wanted to show that people don't use what they call priors. And so in this context, they set us up. The vibe of Steve is clearly soft and withdrawn, and people want to say that it's more likely that he's a librarian. And so there's a little bit of controversy around that because people could criticize, if I'm supposed to say, but the correct answer is farmer. There's a lot of reasons you could criticize that. But we'll talk through what the ostensible reason there is, which is that before you even make the guess, you should ask the question, are there more farmers or more librarians?
There you go. Right.
And start off with that. And the way that you should think of new information is that you have some concept going in, some numerical amount on librarians versus farmers, and that's getting updated based on the new information. And their point was just that doesn't seem to be how people think. They don't think in terms of the updating. It's more like the amount that would do the updating is what's salient. So I think the point they were trying to make is that even a question that you ask ahead of time?
There are 20, I think you had said 20 times the number of farmers than librarians. Yeah, libraries are not doing that well now. So yeah, it's just not something that you take into account, but that we should when we are thinking about these problems. And I thought in this video had a very interesting 2 ways to help you think about problems like this is visual. So you had and instead of just the number 100 farmers, you had like a chart of 100 dots on, and something about saying 4 out of 100 instead of 4%. Even the way you phrase it can help you think. So I loved that. As there are all these ways that I've learned from you of how to think about math problems. So you don't just go in there and be like, oh my God, I'm overwhelmed. What do I do? Do that. simplify it. If it's 3 dimensions, take it down to 2 dimensions.
I think one important thing here is to understand that math is a field of abstractions, and that gives it both its power and also its opacity. And so, like in this case, if you're going to talk about 4%, you can make that more concrete by telling people, think of like 4 people out of 100. That makes it concrete. But the mathematician, they'd even be uncomfortable with 4%. They'd be like, no, give me like 0.4. Or that's a specific number. I'd rather just call it P and then reason in terms of P. Like there's this instinct towards abstracting away. And abstraction does a couple things. It cleans up your thinking because you're not dealing with the messiness of the specific cases that you're doing. It unlocks some very powerful things. There's like facts that you can discover once you phrase it in an abstract language that are hard to see in the cloudiness of the real world. But you pay this price of abstruseness, of it being harder to understand. And I think what often happens is the people who are math savvy, they're so comfortable in the more abstract layers. They're so comfortable there, and they know it feels better because it's more powerful, because their thinking is clearer. It makes it very hard to communicate within the other layers of abstraction. So as a student, I think ruthlessly asking, like if you don't understand, thinking, that's not because I'm dumb, right? It's almost certainly not because you don't get math. Instead, be like, this person is talking at a different rung on the ladder of abstraction. I need them to step down a little bit and just say like, can you give me an example? Can you give me an example of that? Like rather than saying, I can't get this or I'm not a math person, just keep asking for examples until one of them hits. And that it's not going to hit, it's not going to like guarantee a good time. But I think that would go a long way. And for an educator to think similarly, saying, okay, before I get to the abstraction here, can I give a very concrete instance that gets at the same idea? I might be losing something, right? It's not the full powerful generality, but can I give some concrete instance that gets people there?
Hello, Puzzlers. Welcome back to the podcast. We are here with the great Grant Sanderson, the man behind the 3Blue1Brown videos on YouTube. Grant's videos explain in fun and visual ways the math behind everything from Bitcoin to Wordle. Grant, can you tell me about the name 3Blue1Brown, where it comes from?
Sure. I will start by saying I'm not exactly proud of it, but we'll go there. It's when I was just starting the channel, I wanted some kind, have some kind of logo on there, have some kind of name. I wasn't thinking, hey, this is an entity that I want to grow and turn into a career. It was, I had a video I wanted to post. I've got this like form to fill out. What's the channel name? What's the channel logo? I liked the idea of the logo being a loose depiction of my right eye, which has it's not 100% unique, but it's a more unusual coloring where it's mostly blue, but like a quarter of it is this segment of brown. And the channel was about visualizing math. In some ways it's like, how do I see math? And so the idea of like sight and visuals is maybe encapsulated in that, together with, it's the equivalent of someone making their channel name their own name, right? It's like, rather than putting my own name on it, it's this genetic signature. Now, hand in hand with that, I was on a real kick, I remember, about names can and maybe even should be kind of weird, where names that are, they just seem very strange at first, grow on you quicker than you will expect them to. Like Google is a very weird name. For the first time anyone heard it, it's spelling a number wrong. It's just a weird name. Or Facebook is a very weird name, but it's strange how fast they grow on us. And there's an advantage to having something that was weird, where you can grow your own brand into it. So rather than being like, this is the visual math channel, I can make it whatever I want, right? And I can make it occupy whatever part of your headspace I want it to, without unwanted associations into other things. There's no worry about like domain name or social handles. Just like have something that's a little bit more unique. Now, would I recommend that someone name something after a piece of their own anatomy? No, not unless they want to have like a bunch of awkward conversations when they meet people in person who are like really closely looking at their right eye. Do I think that it's easy to say out loud and lends itself to word of mouth sharing? Wait, was it 3 brown, 1 blue, 3 blue? What was that thing? Like, no, it's maybe not the best there. I like that it abbreviates to 3B1B, which is it's like sort of 4 characters that I get to, in some sense, like own the brand space around that. Except for the real estate markets for 3-bedroom, 1-bathroom houses. That one, there's a little overlap. But outside of that, I get those 4 characters. That's mine.
Got it. Well, I mean, it works. Who knows, in an alternate universe, if you had named it something else, maybe it wouldn't have taken off.
Yeah.
So yeah, well, I didn't know. I'm sorry to bring it up. In fact, I'm sorry because I wrote an entire puzzle based on brown and blue. So
Oh, that's right. No. I say that all
hope-
apologetically, but more in the sense of like tipping my hat to the fact that like, okay, I know you think I'm a weirdo. I also think I'm a weirdo. That's more what I'm getting at.
Well, I thought it was very cool. And I do have to ask, what do you put on your driver's license?
Oh, for eye color.
eye color.
I put blue. No, it's never even occurred to me to get more creative on my driver's license.
Yeah,
that's not where my head is when I'm at the DMV. I'm in like creative space.
I actually, when I first heard the name, I thought it was a reference to those great puzzles about eye color. There are 100 brown-eyed people on an island, 100 blue-eyed people, which are really a fun, awesome type of puzzle. Sometimes called common knowledge puzzles or muddy children puzzles. They're very cool. But anyway, this is a different type of puzzle. This puzzle is called 5 Blue, 5 Brown.
Okay.
Because all of the answers in this puzzle will contain either the word blue or the word brown. So phrases that contain either. So if the clue is, this is the name of an Ivy League institution, the answer would be Brown University. If the clue is, this is the name of a famous cave in Italy's in the Mediterranean, that's the Blue Grotto. And we'll be mixing them up so you won't know what's coming next. One final thing, since you are a math person, all of the clues will contain a number to make you feel more comfortable.
Okay. I appreciate that.
Sure, I thought so. I thought it would be nice. All right, so their first one is, this ocean creature has a heart that weighs 400 pounds.
It's got to be the blue whale.
It is. It is sometimes up to 1,000, but 400's minimum.
Wow. 1,000 pounds for a heart.
Well,
wow.
And that is actually quite a small heart compared to the 330,000 pounds that that your average blue whale is. So it's actually a small heart. They're Grinch-like. All right, this character said the phrase "good grief" more than 300 times during the history of the comic strip he appeared in.
Our friend, Mr. Charlie Brown.
Mr. Charlie Brown, exactly. This sentence contains all 26 letters in the English language. It has 35 characters, but it contains all 26.
The quick brown fox jumped over the lazy dogs.
Exactly. There's different variation, jumps over the lazy dog, but you got it. This technology was named for a Viking king. It also uses, you know about this?
I have a story on this. Well, I remember thinking like, where did the name Bluetooth come from? And I asked, I can't remember if it was ChatGPT or Claude, but I asked one of the LLMs, and then it gave me this answer about like this Viking king named Bluetooth. I'm like, freaking LLMs hallucinating on me again. This is obviously false. And so I'm like going, I'm like, that's where it comes from. I'm shocked. And
you are correct, right? It was a Swedish company, and apparently it was like a placeholder name. And they were going to come up with a more serious name, but then they just stuck with Bluetooth. And I do love this. I love because I love things that are hiding in plain sight, like the arrow in the FedEx logo. The Bluetooth logo is a rune, like a Viking kind of letter.
And that specific Viking, it's like, it's apt because he sort of brought together a bunch of different colonies, right? He like lended them, like made more communication, more connection among all of them happen.
Right. Yeah, spirit, exactly. So, I wondered if that was like looking back, let's try to justify it.
Oh, maybe, sure.
But I don't want to be a negative Nelly. How about, this is the only NFL team of the 32 teams that does not have a logo on their helmets.
I'm going to go Cleveland Browns.
You are going to go right. Exactly. Now, I have noticed you've done a couple of sports adjacent stuff, like the darts. You did something on, what was it? 4-dimensional darts?
It's very adjacent indeed. Yeah. If the closest sports content you can find for me is a video on someone else's channel where I do a puzzle about high-dimensional darts, I think that tells the audience everything they need to know about how sportsful this is.
We won't go into, but sports does have a lot of math.
That's true. Yeah.
How about this phase of Picasso's, the painter Pablo Picasso's career? This phase yielded a painting that sold for $67 million at auction. Do you
I
know?
do not know my art history, and
Oh,
I
okay,
have no
good.
clue here. I'm sorry.
Well, I'm glad that makes you more human because you knew your quadrillions and trillions. It's called the Blue Period from 1901 to 1904.
Okay.
And I mostly brought it up because I wanted to make the point that cubism should be called polyhedronism because it's not really cubes. And if you bring that up at parties, people are going to love it. They're just going to be like, I want to hang out with that guy. That guy.
I don't deny that. That sounds about right.
But yeah, because they're not cubes. They're just all,
It's a
in
great
fact,
point.
they're more like cones and cylinders and stuff.
Yeah. Great point.
Thank you. Thank you, Grant. All right, we got a couple more. We got, this is one of the 14 things mentioned in the song My Favorite Things. 14 things mentioned in Howard's Your Musical. We know you're not a sports
Raindrops on
guy.
roses and something with mittens.
Yep. It's more obscure. It's down farther below. It's going. It is.
Is it Blue Ribbons?
Oh my God. I can't believe it. I can't believe it. There are 2 correct answers for this, and I didn't even notice. So yes, blue, girls in white dresses with blue satin sashes. I will accept that.
Sashes, not ribbons.
But actually,
yeah.
I was thinking of another one, which
which
is
one?
not blue, but brown. There's another favorite
brown
thing.
paper packages tied up with string.
That's it.
Yeah.
Oh yeah, you do know your musicals. That's funny.
Okay.
I missed it. I missed the that there is both answers.
Well, it's a great
I'm just
clue,
gonna
then.
pretend.
It's got, it
yeah.
hits both colors.
Yeah. All right, we got 2 more. We got this computer, which defeated Garry Kasparov in chess in 1997, could evaluate 200 million chess positions per second.
Deep Blue.
That's it, Deep Blue.
Well, just the word deep is used so much in modern machine learning to refer to deep learning with neural networks, but it wasn't neural network based at all. It was like the word deep for a completely different reason. So deep is in the lingo of machine learning these days, but it was like it kind of has a different meaning than it did then, which is
interesting. Well, yeah, it sounds good. Like you want something that's deep. You don't
yeah.
want shallow blue.
No, yeah.
All right, well, let's end with one that has a big number. This company's fleet of airplanes flew passengers more than 50 billion miles last year.
Yeah, I want to say Delta, but
well, remember the constraints. It's got to be.
I'm sorry.
You took a break, so that
I forgot what game we're playing. Oh my god. I just assume I'm like, is this the biggest number? Like, what's one of the bigger airlines? Okay, JetBlue. I'm sorry.
It is JetBlue.
Yeah,
Nicely done. Listen, you took a break, but you got it. JetBlue. Well, thank you, Grant. That was a joy. I loved it, and I recommend people should go to 3Blue1Brown's.
It's not good for word of mouth.
But it is good for search engines. Any other place that you recommend people see you?
If you Google that or my name, you'll see things. But the YouTube channel is sort of the central hub for things. Listeners to your podcast should feel no pressure, but if they're in the mood for some visualized math, I'd be honored if they wanted to take a quick look.
I highly recommend a lot of them, but do check out the one with the bouncing boxes. What is the title of that one?
I think it was just the most surprising answer to a counting question.
There it is. The most surprising answer to a counting question. Google that, and Grant Sanderson. Thank you, Grant. Thank you, listeners. And one other important note before we go. We have a Patreon. Patreon.com/HelloPuzzlers. Just like Grant. Grant has a Patreon. So check it out. We got all sorts of cool stuff, chats, and you can hang out with me and Greg, and bonus episodes, exclusive puzzles, newsletters, and more. And of course, we will see you all here next time for more puzzling puzzles that will puzzle you puzzlingly.